Okay, so today I would like to focus on real user stories from three different universities from our customer and how they actually run their AI cluster based on the Backend.AI. And yeah, all this story start from a single question. It is the one the administrator students say, "What is this black screen?" Oh yeah. So the this university differ in size and structure, but if we strip away to a surface, the main challenges and the main goals should around be same. The start with the common challenges is they always have a limited GPU and a lot of the resources are limited. Plus, they have rapidly grown AI at the demand, and of course, the hardware is expensive and scattered across the labs, or it can be a project say, by the department. And very few people with the time or expertise to run their clusters. Also, it is difficult to give fair control access to many users and little visibility into who use what and which purposes. So the common goal should be let hundreds users, hundreds students and researchers use their infrastructure easy, and it's a standardized infrastructure management without any much lighter overhead, and share one clusters across the many groups and with the clear separation and the policy basis. And C to explain how institution resources are actually used and the maximize impact to every resource, GPU especially for the university they buy. So yeah, this is the first case, which is the business school at the university, the Kookmin University in Korea. This is a business school, not a computer science department. So they started with the 3 server, just from the 16 GPUs. At that era, the 80 students from the outside, the MBA students have to take the class, have to use their resource at the same time inside the classes. But since we base at the Backend.AI, the GPU virtualization that can be possible through our Spice GPUs in a container level. Now they expanded to a 60 plus GPU. The 60 plus GPU, the infrastructure, now operated by the 2 rotating non-CS students, TA. And there are no dedicated APC team, HPC admins. Plus, there are still using very well about the hundreds of students running a various environment and a labs with the parallel. So the design, the goal is quite straightforward. The TA, the Michin students, they should behave more like a course coordinator, but they cannot be the system administrator. And the students should be able at a login, just choose their resource and ready to go. And on top of the AI, as container-based sessions, we can serve the hundreds of the development enterprise as a parallel. And so as a result, at the AI teaching cluster would be 100 students run labs simultaneously without the dedicated HPC admins. So yeah, when every year that I mentioned with a 2 non-CS, the administrator will be assigned it, and there are no majoring at all. In this case, the first question we got called from the last year was, what is this black screen? So they have no experience about CLI, no experience with the SSH, no experience at HPC, or even from just how to manage the cluster. But based on our Backend.AI above the GUI level, they can just easily manageable by the whole cluster from the single to non-professional administrator. And the second case is a supercomputing center from the Seongyungan University. They operate more than the 4800 GPU clusters, and over thousands cores, CPUs, and about 2 petabytes of storage. This is the first case about supercomputing center since 2022. So previously, each lab owned by their own servers, and now the researchers are kind of consolidated into university level center. So the goal was just not owning a big system, but to let the researcher group share the infrastructure and fairly and allow them to configure about the environment need to be themselves. So top of the Backend AI, Sungkyunkwan University gives the researcher as a self-service environment, so to speak, and via the portal, via the web or app, where they just pick the container image, just request about how many resources they needed, and just start and stop the session. That's all about it. And the Backend AI provide detailed usage, such as GPU hours, how many uses, how many resources they're going to use, and how many per lab, or it can be a person. So they connect their own billing system with our specified data and making as an internal billing system. It can be a GPU as a service, right? Local with the local infrastructure they own. So and user just directly bring up the environment what they needed when virtualize whole cluster into one single platform it is. And our next use case is of course the University of Southern California. USC is already run the strong department level HPC cluster from the lot of histories, but now they expanded to a GPU basis AI cluster. And USC admin CARC admin, the BD Kim says, the students cannot truly make use of this resource, the school provides those resources do not truly serve their students, which means that all the environment from the infrastructure should be harsh free. It should be helping the developer. It should be helping by the researcher. So using the Backend AI, US CARC team is moving toward about the consolidating into each labs by department to GPU into campus-wide shared pool and managing from using courses, using research from any environment what they required in, and through a single platform. So students research regardless all the department can request infra through a single platform with the central CARC team and from their IT office. So it can be planned as an investment basing using this platform. From the USC, so Backend AI is less about brand new hardware architecture cluster, but it's more about optional layer that ties existing hardware from a new hardware campus-wide supercomputing pool. So yeah, just talked about we look at the stories, but let me briefly just summarize what is the Backend AI. So it is, you can access directly as you see the GUI, or it can be joined as a CLI. So we have as a low level, we have a patent container, we have a patent technology called the container level GPU scaling and a virtualization. Also, based on the tech, we built our in-house made orchestrator, including the intrinsic multi-tenancy, multi-node support from the start. So it can be possible from a single PC, or it can be possible up to 1,000 nodes as a data center from a single platform. So our main goal is virtualize it, containerize it, so maximum resource utilization is the main important thing. Plus, above our core, the AI cluster management platform. So our enterprise-grade technical support should be included as a top-class performance. Yeah, so our goal is let the hassle-free. The administrator should be lean back, enjoy, and then it will be keep automatically run by our own scheduler, our own orchestrator. And the mention that are about HPC management should be our Backend AI course, but not only we just infrastructure management, but also we also provide for every aspect of the AIs. It can be started as a just development environment, but it will be extended to the inferencing. We can directly connect to the Hugging Face, or it can be an MLOps platform we included as a fast track. Or it's just, I just want to service the model, it can be just directly serviced to our same platform at the single page. So you can just demo, there's a lot of good demo right there. So if you want to know, just let me know after the session. So yeah, thank you. So our main goal is make AI accessible, make AI scalable. It should be harsh free. We build a product that make it easy to operate and AI scales. Thank you.